Okay. Turn these bad boys on. What I think happened is I ran out of juice. See? I think I just ran out of juice. So that's why I blue screen. Or if I don't have it configured.
I don't think Windows 8 has a blue screen. Not like that anymore. It's just like an unhappy face.
Unhappy face.
It's like very not useful.
I cannot stand Windows 8. I'm sorry. I am not impressed.
It's just Windows 7.
It's Windows 7 much harder to use.
Yeah, Windows 7 much harder to use. You got that right.
Yeah, if you don't have a tablet, it's alright on a tablet.
Because I think PC sales declined like 37% this quarter.
37%?
Yeah. Like
Why?
No one wants to. Well, I guess because manufacturers rely on new operating systems to get people to upgrade. And
Nobody wants to upgrade.
wants one, but it has like terrible word of mouth.
Oh yeah.
So no one will do it.
Yeah, it's from what everything that I've read about it and experienced with it thus far, it's been really bad. .68.109.29. Alright, so I'm back to where I was. So I'm going into router OSPF 100. Then I gotta tell the network that it's gonna participate in it, which is 201.68.109.128. And then the wildcard bits. So what are the wildcard bits? Again, like an inverse mask of that. You made up. Can you tell me?
Wait, which one?
If I am doing a wildcard mask, a wildcard mask is an inverted subnet mask. Instead of counting bits from the left, I count bits from the right. What would be the inverted mask of a /25 network?
0, 0, 0. 128 though.
128 though, not
Yeah, because it's
20. Yeah.
yeah.
So
So
it would be
/25.
0.0.0.
128.
No,
What was 0.0.0?
almost. You're off by one. 127, because you count the bit markers from the right, not the left. So if you count the bit net markers from the left, like you do in a subnet mask, it would be 128. But if you're counting the 7-bit markers from the right, 1, 2, 4, 8, 16, 32, 64, those add up to 127.
Just subtract 1. So would you always subtract 1 though?
Yep.
Okay.
If you're doing an inverted mask, yes. 0.0.0. Oh, incomplete command, because I got to tell it what area it's participating in. So what area am I participating in? There. 0. Okay. Perfect. Now, to check your routing table as you build your network on any of your routers, you use the command show IP route. Okay? And as you can see here, I have the 201 network, and I'm also seeing the 134 network because I'm getting that through DHCP. Okay? So let me go over to router 3. I'll come back to router 2 in a second. Let me get this thing going. Let's see, int f00 p add 20 something or other.
68.
201.68.109.131. Shut. Router OSPF 100. Network 201.68.128.7. Now watch what happens. I'm gonna bring up R1 here real quick. Watch what happens when I enter this command to both R3 and R1. If I did everything right. If I did everything right. Okay. What went wrong here, Chief? Okay. One, three. Oh, there we go. I have connectivity, so I can ping it. Something else went awry. Let me look at my OSPF configuration here, see if I can figure out what in the world went wrong. Ah! See that? Fat fingered it. So here in R1, so why you gotta troubleshoot as you go. Router OSPF 100. No net. You get these, once you do it correctly, you will get adjacency notices. And the routers will start talking to one another, and they will start sharing networking information. Now, let me go back to R3 here real quick. If I do show IP route now, okay, I still only see the two networks because I'm not learning anything new. But if I go here to R3, and I implement this network and tell it to participate in OSPF, alright, and I give the network command net 172.21.0.0 0, inverse mask, until it's participating in area 1.
What is that? That up arrow Z or the control Z?
Control 0.
I mean, yeah.
That means I just went from configuration mode. I can go from like this, the router configuration mode. If I hit Control Z, I back all the way out to privileged exec mode. It's a hotkey. So once I do that, if I hit Control Z, watch what happens. Control and Z, I go all the way back to privileged exec mode. Okay. Now if I go back to R1, after doing that command in R3, Control Z, show IP route. I now see the 172.21 network as being learned from OSPF as an inter-area route. So R1 now sees that network. No static routes put in. You know, it learns it automatically. That's why they call it dynamic. So now let's go over to R2. Real fast. And R2, as you can see over here, we not only have OSPF, but we also have EIGRP. Come on, R2. Host name. So I'm gonna address both of them real quick. And then I'm going to go into router configuration mode. Router OSPF 100 net 201.68.109.128 area 0. It now joins the OSPF community. So last thing I have to do is I have to configure EIGRP. And to configure EIGRP, same way, same methodology as OSPF. Router, EIGRP this time. Okay. Then the autonomous system number, which is 25. Changes to the routing protocol configuration mode. I tell it network 192.168.50.0. Wildcard mask 0.0.0.255. It's a class C. And then I'm going to type in auto summary, which means it'll auto summarize routes. Okay? Now once I do all that, I'm going to do a show IP route here at R2. And as you can see, R2, I can see, of course, the OSPF network here, and the 172 network over here, which is good. So he sees all its routes. But I really am concerned that I have full connectivity everywhere else. So I'm going to go back to R1. If I do that again here at R1, oh, I didn't give R1 a host name. Host R1. Show IP route. And you can see that. Wait a sec. What am I missing? What am I missing? What? You're on to something, Sam. Almost. What am I missing in this routing table? No, it's connected to the network. Because I can see the 172 network. I can see this network right here. What am I not seeing? Right. I have not seen the 192.168.50 network. Now, golf clap. Who knows why? This is a hard answer. I'm not expecting. I just want to see if anybody knows. No, I configured R1 perfectly. R1 is almost all done. I'm missing one thing from R1, but I'm gonna come back to that. On R2? Yes, I did not configure something on R2. When you have what they call a border router, or in this case, it's called an autonomous system border router, or ASBR, because I have an autonomous system here, OSPF 100, and I have an autonomous system here, EIGR 25. Okay. When I have two different dynamic routing protocols, I've got to tell at least one of them about the other. Okay?
Does it matter which one?
Yes. I'm getting to that. Okay? So, since my boundary is right here on R2, okay, I've got to tell OSPF that EIGRP exists. Now, say that this was not a computer or a server, but this was another router, and it was just connected into EIGRP, right? It had other networks below it. I would then also have to tell EIGRP that OSPF exists. Okay? But just because this is like the end of my network, I only have to tell OSPF that EIGRP exists. Okay? Now, I do that under router OSPF with a command called redistribution. What redistribution does is it allows for those routes or those networks that are learned by another routing process to be automatically configured and put into the other routing process. Okay? So basically what the redistribute command in R2 under OSPF is going to do is it's going to tell it, look, any EIGRP networks or routes that you learn, automatically put them into the OSPF routing process so that other routers can share that information. Okay? You do that with one command on R2. While that's timing out, come on. How you don't come across that domain server, no IP domain dash look. Quick shortcut. Anyway, router OSPF 100. Then the redistribute command is redistribute. The routing protocol that you want to redistribute, which in this case is EIGRP. The autonomous system number of EIGRP, which is 25. All right, and then different routing protocols are going to have different parameters. For hybrid routing protocols and distance vector routing protocols, i.e. RIP, you always want to use the subnets command in there. Complete the command. So you consider subnets for redistribution into OSPF. Otherwise, it will only redistribute along classful boundaries. So if you have a 10 network, right? Say you have 10.0.0.0/24, it's going to advertise that as 10.0.0.0/8 because it'll take it along classful lines. Once I do that, if I then go to R1, it updates darn near immediately. You now see that R1, if I go to R3, it would be there too, that this network is there. And it's advertised as an OSPF network from an external source, external type 2. That's how you make routers learn about other networks through different routing protocols. Now, one last thing I need to go over tonight. Default routes. Now, we had a default route. We had to create a default route in Lab 1, right? Well, we're going to create a default route in R1. Actually, if we look at it here, okay, since this is DHCP, I'm already learning the default route. It's just not showing up in my routing table. Okay. I can do a IP route 0.0.0.0.0.0.0. If I'm using DHCP, I can tell it the IP address of the next router if I know it, but if I don't know it, I can tell it just to go out that interface. So I can tell it fast Ethernet 00. Now, there's my default route. If I show IP route, yeah, now I have a default route. Okay? So now if I go back to R2, well, R2 doesn't have a default route. So how would R2 or our stations on the 192.168.50 network know where the internet is? How do they know how to get there? Well, I could make a default route and point it to R1. That kind of defeats the purpose of having a dynamic routing protocol, though. So what we can do instead is go into R1 and tell OSPF to advertise that default route. All right. Now, a lot of protocols you can do that with a redistribute command. All right, and just redistribute static. Well, redistribute static works if you have specific networks that you're advertising. If you're advertising a default or general route, you cannot do that. You have to use a different command called default-information space originate. Default information originate. Write that down, commit that to memory. You need to find that. Some of you will lose points because you don't remember it. I'll show you right here. Router, go into your OSPF process, OSPF. Default dash information space originate. When I invoke that command and I go back to R2 and I do the show IP route now, you can see that that static route is learned. If I go into R3 and do the same thing, you can see that R3 has full connectivity as well. It knows about the 192 network and the default route. So you've got to do all of that to get number 2 right. Got 10 points. Okay. Now what took me just about 35-40 minutes to show you, okay, add about 4 more routers in the CCIE routing and switching command, routing and switching lab, okay, you do all that in about 10 minutes. Boom, 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 boom. It's muscle memory. It's muscle memory. Okay. Last but not least, number 10. Now that we've gotten our OSPF working, let's break it by putting in area authentication. Now, area authentication, if you look at lab, I didn't bring up lab 2. Lab 2, it's asking you to do area authentication in area 0 with MD5, an MD5 hash with a pre-shared key of Cisco. Okay, there's 2 ways you can do this. One, you can look through the book because it's in here. Oh, I'm sorry. You can look through the book; it's in there. I forget which chapter it's in, but it's in there.
You want to take a look?
No, you're fine. You can look if you want to, or you can Google it.
Can't pull it up from the help menu now.
Huh? Oh yeah, but you don't. You can search through the help menu all you want. Trust me. If you type in Cisco OSPF area authentication, it's the first one that pops up from Cisco. Yeah, it was me. Cisco OSPF area authentication. Click on that. Now there's 2 types of authentication. There's standard authentication, okay, or actually 3 types of authentication. No authentication, this is called type 0 and it means no authentication, which is what we have now. There's no authentication. There's plain text authentication, which is called type 1 authentication, and it uses simple clear text passwords, okay, so you're just sharing a password. Big deal. I can sniff that, no problem. Then you have MD5 authentication, which is type 2, and it uses MD5 cryptographic passwords. Okay? You're going to do the latter. This is a security class. You're going to do the latter. You scroll down. It's the second configuration. You have to put a command on the interface, and you have to put a command under the OSPF process. All right? So let's do that on R1. R2 and R3. Router OSPF 100. Then you want to do area 0 authentication message digest, and then on the interface, which is F01 IP OSPF message digest key, whatever key you're using, you have to give it a variable, which in this case I'm just giving it 1 because they all have to match on every router. Okay, MD5, and then your key, which I said you're gonna make it Cisco. Now, if I wait long enough for the OSPF timers to time out, that's gonna break my network. That's gonna break my network. All right. So if you're ever doing this on a WAN, you want to do the far side first. If you do the near side, then you're just gonna lose connectivity. Okay, see, the adjacency changed, it's down, it's the dead timer expired. I've lost connectivity. So now, if I go to R3, and I do, what was it? Area 0 authentication. Message digest. IP OSPF. Message digest key 1, MD5. Cisco. It'll come back. Finally, on R2. Area 0 authentication. Message digest. Int F00. IP OSPF. Message digest key 1 MD5. Cisco. And they'll come back. There they go. To check, the check for this is to just look at the interface. So show IP, actually, show IP OSPF interface F00. Okay. Here at the end, it will tell you message digest authentication enabled. You've got to do that on every router to get all 10 points.
Were you saying we should go from R3 to 2 to 1?
It doesn't matter for the purposes of GNS3. It doesn't. If you're actually doing this in the field, if you're sitting, say I'm sitting at R3's site, and I do R3 first, I'm gonna lose connectivity with R1 and R2. I gotta put it back. All right. If I SSH or telnet to R2, right, and I do it there first, okay, I have got to get the command in the router and on the interface, or I've got to backdoor it somehow in order to set it up, or I have to have somebody on that site set it up simultaneously with me. Otherwise, you break stuff. And then you're like, God, how do I get to that site? And what if that site is like, across the campus, or Santa Monica, or Vancouver? You get the picture? Any questions? Not that I mind going to Vancouver. Huh? It just popped into my head. It just popped into my head. I could have said Wisconsin. Whatever. All right, I'm done for the night, guys.
So is it like mainly on chapters 5 and 6?
Yeah.
So, go through the, okay.
Yeah.
5 and 6.
So, fun times.
I like this book.
The other thing with the lab is pay particular attention to how I want you to do the ACLs. You will not do one ACL. You will not do two ACLs. You'll do at least 3 ACLs in this lab. At least. You could do more depending on how you put things. Watch where you need to put NAT. You can put NAT in a couple of different places. You can put NAT on R1. You can put NAT on R2. Right? I think I tell you where to put port address translation. All right? But if you put NAT on R1, then you need to put ACLs in a specific place. If you put NAT on R2, then you can put your ACLs in a couple different places. All right? They're dependent upon one another. I'll go through a little bit more of this on Wednesday. I'm going to go through the radio server. All right. Good night, guys.
This is due next week?
Next Monday. I may extend it, though, because if I make it due next Monday, that means I've got to grade it while I'm in Vegas. That's not going to happen. So you'll probably see an announcement come Wednesday that it's going to be due a week from Monday. All right?
Not too late, most likely will be
No, most likely the week from Monday.
Oh, the week from.
Yeah.
Okay, that's cool. That's even better.
Don't thank me, thank the IBJJF.
Thank you, IBJJ.
Still gonna do it this week.
It's fine.